Yeah, I will talk about open notebook science and open notebooks in cognitive neuroscience. And I will basically start by saying general things about taking notes. Because like obviously there are varying degrees, varying people here. And then I will talk more specifically what is open notebook science and why I think we should adopt this and why I think this actually solves a lot of problems we are discussing. And I think it nicely ties into what a lot of previous speakers have already mentioned, so I don't need to reiterate this. So jumping right into it, I think most in this room already keep notes of some sort, and I think we generally agree that keeping notes is a very important thing of our work. I think, however, keeping some ways of keeping notes are more efficient than others, and especially are more conducive for sharing and doing open, reproducible science. As this example here, it might be very difficult. For you, it makes total sense if you come up with a system, but to actually share this kind of collated notes to someone else might be very difficult. So my aims basically today are saying general things about taking notes, presenting my approach to open science, and then hopefully finishing with a stimulating discussion with you guys. So basically, why should we keep notes? Very, very quickly, it's a form of documentation what you actually do. In the end, so like if you want to publish something on your work, it will definitely help you to write this down. And also, it can't be, so like people already did say this previously, but it can't be stated too often. Your most important collaborator is your future self. And you'll need to assume that you basically know nothing about your own work in the future. So this leads us to what should we keep notes of? Obviously, your ideas, you'll forget them if you don't write them down. You should write down, like, why did you choose a certain parameter? For instance, in an experiment, why did you present the stimulus for a certain time? If you design an experiment, it makes totally sense why you choose like 2 seconds. In half a year or like a year, you have no idea why you did this. So if you actually take notes and why you did this, this will be easy also to defend your work if a reviewer asked you why it took 2 seconds. Same applies for rationale for analysis, and like basically can be summed up by anything which you need to replicate your analysis. And I think we can learn in general a lot like how wet labs organize their labs and their notes. There basically everything is broken down into an easy follow recipe where everything is written down, and then like, but for us it's mostly like you'll need to find a balance of how detailed you want to be, how detailed you want your notes to be, and still make efficient use of your time. So how should we keep notes? Just in general, coming back to the point that your future self is the most important collaborator, write them for someone else. And this even applies if you don't adopt, as I would suggest, an open notebook. So like even if you don't publish them, write them as if you write them for someone else, because like only this really ensures that even you will understand them in the future. Because you just need to assume that like your future self understands as much as the stranger of your work. So obviously you need to organize your files and data. We have already had very nice examples how you can do this. This applies to file names, right? Email files. Oh, sorry. So like I don't need to go into this again. You need to link your notes to the project into files. So this actually makes any kind of sense. You should order them chronologically, use timestamps, think about permanent data storage and backups. And then a thing I propose is use electronic notebooks, such as Jupyter or RStudio and Markdown, where you can basically embed your code into text, where you describe your analysis, your interpretation, what you've done, and basically have the code which runs your analysis in one document. And a lot of people might not know this. Jupyter as well as RStudio and Markdown do not only support Python or R, like a great variety of programming language. So like even if you're not using R and Jupyter, Python, you can still use those notebooks. And we'll see how useful they are to create Open Notebook later on. So basically, so much for taking notes in general. Basically, now I really want to move on to what is actually Open Notebook Science. So what are Open Notebooks? Open Notebook Science, which is basically just the umbrella term, is about making the entirety of your research publicly available. The term has been coined by John Combe Bradley, 2006, who is a chemist, also in a discussion with Peter Murray Rust, who will be following my talk. So it comes from a kind of different world, but I think it's very useful for us as well. So basically, what an open notebook is, like already a lot of scientists, as we already keep notes, some of them like in a paper version, some of them in a collection of like a lot of sheets of paper. Some of them just use the binded version of a book. And an open notebook is basically boiled down to an open version of it. So much for that. So like, let me basically explain what I've been doing for the last year. When I started my PhD, I've been keeping an open notebook myself, where I basically, so like the last year, I basically tried to find a working approach to keep an open notebook as a cognitive neuroscientist. And I started with like sometimes very short daily posts describing everything I did, which was just not sustainable, not a working approach. And basically the way I did it, I had like my website, which was hosted on GitHub Pages, was basically hosted at like a friend who has a web server, and an index file where I list all my R Markdown files, where I basically have all the done I did in R Markdown files and just listed them chronologically. But they were really pretty detached from what we're actually doing in the entirety of my work. And so I sat down again and tried to find a better way to do this, and tried to find all the problems that like this is not really interlinked and not actually not reflecting the entirety of what I'm doing on the everyday basis. So I developed a new approach, which I think is more suitable what we are actually doing in cognitive neuroscience, which is simplified in this nice graphic. So basically what happens and what I'm proposing is most of the work we actually do should be done in this box here, which is separate Git, can be a different version control software as well. I'm using Git, or I'm proposing Git here. Several Git repositories, which are centrally hosted on GitHub. Again, can be different website for you. But basically they're split up into projects. So like one project can be an experiment, one can be an R package, one can be like a simulation, something completely different. But everyone has, every of these projects has their own repository. And if it's an experiment for which I have hypothesis, which I want to test and I know before, then it's generally a good idea to pre-register it. So this ties into the experiment. But basically, all these projects then tie into my open notebook, which is then hosted, which is created by an R package called Blockdown, which I think is very, very useful. And you'll see in a second why I think it's very useful. And then you can just host it to any web server. And you can also include this, host this on GitHub. So it's basically free and very easy to set up once you know how it works. And the good thing about this kind of way of doing it, you can basically decide at which point you really want to go public with the project you're starting. So like if you start a very premature project, maybe you are actually afraid of like people stealing your idea, you can start with a private repository. If you're like a student, you can get it for free. If you're like not a student anymore, you will need to pay a bit, but it's actually not a lot of money. So like you can decide at which point you make your nodes and your repository open, but the crucial point is that basically every change you make to an analysis script, to an experimental script, is version controlled and documented there. And this is basically the point where you, when you change the presentation time of a stimulus, you can change why do you change this to this particular value. And through this you can actually really try to understand what you did when and for what reason. And so in practice, this will look something like this. So like this is one of my repositories, just migrating to the new system. So it's very new that I basically developed this. So like I start with like, this is like a sample repository which I'm actually using. I just collected a couple of ratings for stimuli I needed to do a next experiment. So I just have this. Then I have a markdown post. So like this is basically my new notebook webpage, which is created with this R package called Blockdown, which is, I think, looks very nice. You have like a lot of like text which link to all the different things like repositories, analysis. So like basically, if you're just interested in one of my projects, because like you read this paper but you don't believe it, so you can basically just click on one of the tags and then see like all the posts which relate to this. And if we basically look at this one here, this is just like a markdown document which I created, which, as I said, embed code into text and basically shows this alongside. So why do I think this actually solves a lot of problems we have? So there are a lot of benefit for yourself and for our field. Starting with our field, it would definitely improve reproducibility. First reason is because the whole process of the work from the very start, when you actually set the project up and you create your first file, to the very end, when you finish your manuscript and you can send it to being published, or like it's published and you have like the final version on your computer. And I think the gold standard actually is, and this also ties into the question, best practice versus good enough. The gold standard would actually be people without your help are able to build up on your work or even continue what you do, even if you are not there anymore. So this would be the gold standard. And I think having this kind of open notebook approach is very helpful and very conducive to do so. And another thing basically comes to who is actually going to read your notebook. It's not everyone, and not everyone should read everyone's notebook. This would be just too much. We are far enough to read just as we are right now. But so if you think about only like very few people in the world are actually doing the exact, like very similar things to you. And if you think about like all the projects that might not end up into a publication because like didn't work, you're like too busy at the moment to write up a new result and worry about like where do I send this to? You haven't pre-registered it, so it doesn't really a problem. So like you just make your repository public, make your node public, write a very short like document onto it about it, and then put it onto your notebook, and then you can actually share this with like the 10 other people, other groups in the world who might be interested, and then see, oh, if I do choose this parameter for this particular thing, it doesn't work, and they don't need to do the same experiment to figure this out, but they can just look at you the way you did it. Also, we talked about it's very obvious sort of about like long-term usage of data and what knowledge we create. And I think this is also very important from a perspective of having like a long-term comprehensibility of what you actually do. For yourself, there are also a lot of benefits. The first one is you can convince skeptics of your work because you can show them this is everything I've done, every change I've made to every file. You can check it yourself if you don't believe me. And another very useful thing is people can actually catch mistakes in your work before you actually submit something when it gets more embarrassing. So obviously this is a very good thing. It makes collaboration very easy, mutual learning. People don't need to reinvent the wheels every time they do something. They can just look in someone else's notebook and then adapt it from their own self. And you can do this as well. When we talk about publication and sending something, you can actually point reviewers to your notebook to make sharing much easier, much more efficient. And also, a very good thing is you have access to your stuff wherever you are, at least as long as you're in internet connection. It also improves your employability, even outside of academia. If you think about, a lot of times you need to have much more meticulous records in your work outside of academia. So very quickly, what are possible downsides? I think they can be easily debunked. Time invested for me is like the biggest issue to actually write down notes which are comprehensible for other people. Fear of scoop can happen, but on the other side, actually open notebook science can help you because you can point to a point online. This is when I published this. I did this first. so that you can actually it can help you to prove that you came up with this first. You decide when you go public, when something is at very high stakes. Fear of rejection by editors might be a thing. I think here we can look how things are handled in terms of preprints. You might fear that your reputation might suffer, or your work is misinterpreted. And I think for this we need to change our attitude and really realize making errors and mistakes are okay. We all do them, and the only way to do better science is to acknowledge this fact and be not ashamed of errors. And this also obviously involves having documents online which are not proofread 10 times as you do with a publication. And lack of recognition, basically people still need to cite you. They'll email you and say how helpful it was maybe. You can choose a license to basically determine how people can use your work. So basically, just 4 different small action advice if you really want to adopt this. Use version control, which also includes data. This can serve as a backup. Here you really need to be careful not to accidentally disclose any personal identifiers. The content is really up to you and your discipline. And in general, you should keep it very simple. So basically, as a closing remarks, I say, for me at least, the open part is not really my problem about open notebook science. It might be different for other people who already keep meticulous record of what they do. I think open notebook science can be the gold standard in our field with maximal reproducibility and accountability. Having said this, though, it shouldn't be another source of stress and pressure. It should be a voluntary exercise, which should be inclusive, and I take another way of bullying people. And definitely open notebook science shouldn't replace peer review, but complement it. And these are my resources. This is the block-down package I talked about, a nice introduction for psychologists, for Git and GitHub, current notebooks in our field, and I also want to point to the Open Notebook Science Network, which is a very useful form of resources. And just letting people take pictures. That was my talk.